Hi everyone. Now that we have learned all that we need to know about mole, volume, mass, and number of units, I would just like everyone to see this as a big picture of how mole is the center of all the calculations that we are doing. We can convert from mole to mass, from mole to volume, and mole to number of units. And let's just look at from mole to mass. From mole to mass, again we multiply by molar mass and the reverse is divide. From mole to volume, we multiply by molar volume and the reverse is divide. And for mole to number of units, this one I've briefly covered only, but I think it's good for me to cover it again. From mole to number of units, we multiply by Avogadro's constant. Sometimes we can simplify by writing L, or sometimes you might see as Na. So this is 6.02 times 10 to the power of 23, and the reverse is divide. So a way to remember is this: mole is a very small unit, whereas number of units, they are very large. So from a small number to a big number, you multiply. From a big number to a small number, you divide. So there will be questions that will be asking from mass to volume, or even from number of units to mass or number of units to volume. And mole is the connection between all of these units. So let's just look at some examples. For the first example, we are given the mass of ammonia gas, which is 4.25 gram, and we have to find volume. So from mass to volume, we need to find the number of mole first. So we need to divide by molar mass, then multiply by molar volume. You may pause the video for a while to try this example. Alright, the answer is 6 dm cubed. The first step, we divide by molar mass, which is 17, to get 0.25 mole. And then from mole, we multiply by molar volume, which is 24, we get 6 dm cubed. So that's for the first example. For the second example, we have volume and we have to find the mass. So now it's the other way around. Take note, this is in cm cube. So you may pause the video for a while to try this example. Alright, the answer is 0.8 gram. The first step is to divide by 1000, we get 0.6. And then we divide by molar volume, we get 0.025 mole. And from mole to mass, we multiply by molar volume. For oxygen is 32. So the answer is 0.8 gram. For the last example, this might be a little bit more complicated because of the large number. In this example, we are given the number of molecules of chlorine gas, and from number of molecules, we need to find the volume. So remember, when we have a large number, we want to convert it to smaller number. We divide by Avogadro's constant, which is 6.02 times 10 to the power 23. So you may pause the video for a while to try this example. Alright, the answer is 3.6 dm cubed. First step, we divide by Avogadro's constant, we get 0.15 mole. And from mole, we multiply by molar volume, which is 24. And we get the answer for 3.16 dm cubed of chlorine gas. So these are the examples whereby we need to perform calculations to get the number of mole, and from number of mole we can actually find any of these mass, volume, or unit, number of units. So let's say if we are to find the mass, we can also do that. 0.15 times 71, because the mass of chlorine is 71, and this is the answer for mass. So as a conclusion, this is the relationship between all these: volume, mass, and number of units. And mole is the center of all this, whereby from mole we can actually find volume, mass, and number of units. Just remember the relationship that we have learned so far and summarize everything into this diagram. And that's all for today's lesson.